We are going to finish up our notes for 2.7. We are talking about finding inverses of functions. So the first two examples here, we're just reviewing what we looked at last week. Earlier today you said we switch this into just a y. F of x is like a y. And then we switch x and y. So this is going to become x equals y plus 3 divided by 4. Then what's our next step? Okay, we're going to multiply the 4 over. We're basically trying to solve for that y. And then our last step would be to subtract the 3. Okay? Now, that is equal to y, but what we have to decide is, do we leave it a y or do we change it to that inverse function notation? So I want you to think about it. What would this look like if we graphed y equals 4x minus 3? It's just a slanted line, yes? Y-intercept of negative 3, excuse me, slope of 4. Would that pass a vertical line test? So it is a function, so we would say 4x minus 3 is the inverse of function f. Okay, now, could we have figured that out, that it would be an inverse, before we even started this question? Remember, there's a test you can do on the original function. And the original function was y equals x plus 3 divided by 4, or y equals 1/4 x plus 3/4, if we split up that 4. That's still a line, right? It's still a slanted line, has a slope of 1/4. It would pass a vertical line test, which tells me it's a function. And it also passes what? The horizontal line test. Because it passes a horizontal line test, it tells me that the inverse one will pass a vertical test. Okay? So we do know right away that it is a function. The second part of this directions here say, prove algebraically that these two things that we have just found are inverses. To prove algebraically, we have to do two compositions. We have to take the original and compose it with the inverse. We have to take the inverse and compose it with the original. All right, we have to go both directions, and in both cases they have to equal x. Okay, so we're going to go through this and actually prove it. So let's do f with the inverse. So that means I'm going to start with function f, and that function said take something, add 3 to it, and then divide the whole thing by a 4. Yes? And in place of that x, we are going to dump in what? Yes, we're going to put in a 4x minus 3. Okay, so we've dumped that inverse function inside the original function. We have two things that are opposites. I see a multiply by 4 and a divide by 4. I see an add 3 and a minus 3, right? Those should cancel each other out, but the order that they cancel in matters. So which things are going to drop out first? The 3's. Because that whole numerator piece is being divided by 4, we have to clean up the numerator before we do the divide by 4. So this becomes a 4x divided by 4. The 3's cancel each other out. And then the 4's will cancel each other out. We times by 4, we divide by 4. Inverse operations, and they cancel each other. Okay? Now we have to do the reverse composition. So let's do the inverse now with the original. So starting with our inverse function, 4 times something minus 3. And what am I dumping into it? All right, that original function, which was x plus 3 divided by 4. Now what drops out first? Now the 4's have to drop out first. So we end up with x plus 3 minus 3, which then simplifies to just be an x. Okay? So we have proved algebraically that that inverse we found is truly the inverse of what we were given. All right. I'm going to pause the video. I want you guys to try the second example. Find its inverse first and then do the compositions. Okay, so if we have a y here, switching, we have x equals y cubed plus 1. Subtracting the 1 should be done first because the only thing being cubed is the y, so we have to get it alone. Then we can cube root both sides. to get that. Okay? Do you guys remember what y equals the cube root of x plus 1 looks like? Can you picture a cube? Sorry, not cube root. Y equals x cubed plus 1? That twist, and we've moved it up 1. So our original function is going to look like this. Does that pass a horizontal line test? So that tells me the inverse function will also be a function. Okay? So we can say it's the cube root of x minus 1 being the inverse of f. Okay? Then we had to prove it. So we do our two compositions. We start out with the function composed with its inverse. So I'm going to start with my original function, which was something cubed plus 1. And I'm going to dump my new inverse into it. Okay? What cancels first? The cubes and the cube roots. So we end up with x minus 1 plus the 1, which reduces to an x. Okay? Going the reverse direction, the inverse with the original. So now I'm starting with the cube root of something minus 1. And in place of that something, we're dumping the original function. And what drops out first? This time the 1's drop out first. And then the cube with the cube root. Okay? On your test, it's going to be critical that you show me those steps and that you show them correctly for which composition you're doing. Okay? If you say you're composing f with the inverse of f, then you have to start with the original function and dump the inverse into it. Okay? All right. The last little piece that we're going to look at is what can we do if the original function doesn't pass a horizontal line test. Okay? So we're going to start out with y equals x squared plus 1. Can you picture its graph? What does the graph look like? X squared plus 1. Parabola moved up 1. Okay, so let's go ahead and plot our points. Instead of 0, 0, we're going to be up at 0, 1. Instead of 1, 1, we'd be at 1, 2. Instead of 2, 4, we'd be up at 2, 5. And then we flip them over. So this is my original function. And it is a function, passes a vertical line test, but it doesn't pass a horizontal test. That tells me the inverse would not be a function. So, is the inverse a function? No. We can still find the inverse. We can come up with an equation for it, but it wouldn't be a function. Okay? The second thing we ask ourselves, if it's not a function, can we do something to restrict the domain to make it be a function? So I'm going to ask you, what happens if I set my domain to be 0 to infinity? If I only want to use x's that are 0 to infinity, then I'm only looking at this part of my graph, correct? Would that yellow piece pass a horizontal test if I just had the yellow part? Okay, so I can force the inverse to be a function if I just use part of the parabola. Yes? What if I said my domain would be negative infinity to 0? Now which part of my graph am I looking at? Just the left side, right? The part that's still blue? Would that pass a horizontal test? So I can actually create an inverse that is a function by using just 1/2 of this parabola. Okay? So we're going to look at what happens when we do that. Let's start with our domain being the 0 to infinity one. Okay? So if I just use the right half of that parabola, what would the range be? I've stated the domain is 0 to infinity. What is the range? Let's go back to our picture. If we just use the yellow part, we're starting here and going up, right? So what's the lowest y value? 1 and then on up to infinity? Okay. And the reason we often identify both domain and range is that when we find the inverse, those two flip-flop, right? So we already know what the domain and range of the inverse will be. It's just the reverse of what we have for the original function. All right, so we're actually going to do this twice. Once with the domain being 0 to infinity, and once with the domain being negative infinity to 0. Would the range still be the same, that 1 to infinity, on the left side of my graph? Okay. So let's look at our original. We had y equals x squared plus 1. If we want to find the inverse, we are going to we're going to switch x and y, subtract the 1, and then what? And then we square root it. Now typically when we square root it, we put plus and minus in front, right? So we would have x minus 1 inside the square root with a plus or minus. But because we've restricted the domain, we're only going to get one of those. Instead of a plus or minus, we're going to get one version. Now how do we decide which version we get? Well, go back to our graph. When we take just the yellow chunk and we do its inverse, remember it's that reflection over y equals x, the diagonal line? Your x and y coordinates just flip-flop. So this point here was 0, 1. I would have 1, 0. This point was 1, 2. I would be at 2, 1. And this point up here was 2, 5. So I would be at 5, 2. So I'm just getting that half of my piece. When I graph a plus minus square root, I get both the top branch and the bottom branch. This time, since I'm only looking at the yellow part, I'm only going to get the red part for the inverse. So down here, my inverse would just be the positive square root. And because I restricted it, it is still a function. Okay? And then the domain and range would be what? What did we say we have to do? If we know the domain and range of the original, we just have to switch them. So now my domain is the 1 to infinity, and my range is the 0 to infinity. Does that fit with the picture we have up here, the red part? My domain is going from 1 to infinity. My range is going from 0 to infinity. Okay? So, if we restrict the domain to just the left side, all right, the left side of my parabola, all of this is still going to be the same, finding the inverse, but I'm just going to get the negative version of my answer. Does that make sense? So instead of having a positive and a negative, I get the positive version there, I get the negative version here. Okay? If I'm just cutting it in half and using 1/2 at a time. Domain and range here are going to be the reverse of what I have right here. Oops. All right, let's check to see if that works. Let's go back to our picture. If we just take our blue dots and reflect them, all right, 0, 1, becomes 1, 0. Negative 1, 2 becomes 2, negative 1. And negative 2, 5 becomes 5, negative 2. And we just get that bottom half, right? Which if you think of your transformations, right, that's going to reflect it over the x-axis and give you that bottom half. Okay? All right. Our last example. It says find the inverse of f of x equals the square root of x plus 2. Then identify the domain and range of the original and its inverse. We're actually going to do the domain and range first. Let's look at this. If we did a quick sketch, it is a square root graph that's been shifted where? Left 2. So if we go left 2, our square root graph is going to look like that. What is the domain of that? Negative 2 to infinity, good. And what's the range? Zero to infinity. Okay, we're starting on the x-axis and going up. Yes? So when I find my inverse, I'm just going to flip-flop those domain and range pieces. Okay, start with y equals the square root of x plus 2. We've already got a restricted domain. We didn't have to create one. It was already restricted for us. Okay. Switch our x and y's. How do we get rid of that square root? Okay. So x squared equals y plus 2, and then x squared minus 2 equals y. Is that going to be a function? So we can say x squared minus 2 is the inverse of my original. Okay. That, if I just said graph x squared minus 2, is a parabola that's been shifted down 2, correct? But our domain and range are the reverse of the original domain and range. So my domain has to be 0 to infinity. My range has to be negative 2 to infinity. Okay? And if you think about what that looks like, instead of having a parabola that's been shifted down 2, right, we are only going to have the right side of that. If we only started with the positive square root piece, we're only going to get the positive parabola part. Does that make sense? Our domain has to be from 0 to infinity, starting here, and our range has to be from negative 2 to infinity, starting there and going up. We're just going to have the left side of that branch. Okay? All right, your assignment is on 2 different pages. I did put some graph paper on your table. There's just a couple that you need to graph. Let me know if you have questions.